Hi guys, today it's kit time. And you will say, kit time? This doesn't look like a kit. Well, today I want to show you the 3 kits I built. And all the 3 ones are Geiger counters, Geiger-Müller counters. I'm showing you just this as a reference. This is a Cold War relic from 1972, Polish built for the Russian army, for the Soviet army. It's an DP66M dosimeter counter, Geiger counter, that was used till the 80s. If anybody is interested, if you are interested, let me know in the comments if you want to see a teardown and a test of this particular unit. But there are a lot of videos on the internet already. But today it is about kits. And I built 3 kits, and I just wanted to show you how they look, a few details in means of electronics, not about measuring or accuracy, etc. This is something that I'm not the best person to speak about, but about the electronics. These are the 3 sources I'm using to show you the functionality of the 3 kits. First one is a uranium glass. It's called like that. It's fluorescent under UV. This is something that people were in the 20s or even earlier were wearing as necklaces. Look at the beads. And there are cups made of that, glasses, etc. The next thing is a smoke sensor, the ionization chamber of the smoke sensor, and it contains Americium 241. It's a little bit more radioactive than the beads itself. And then, last but not least, Uraninite. It's an uranium ore found from a friend of mine in Switzerland while he was trekking near a mine. And he collects minerals, and he sent me 1 piece. So, and these are the 3 kits I want to show you today. Again, only from the from the electronics point of view. I will not compare them, how they work, the accuracy, etc. I want to show you only how they are built and some differences from the electronic side of view again. By the way, guys, if you like what you see, if you like my videos, please press the like button and subscribe my channel. This helps a lot, of course, to the channel to grow and to give you more videos, technical videos, and some rarities or strange stuff, etc. That would be interesting, that are interesting for me and hopefully interesting for you. So let's put these 2 away. This is the first one. And it's the most easy one to build. It's completely through-hole. It has only a serial port that can be used for the data to show graphically on a PC or, I don't know, on a display. Otherwise, you have only this beeper here that will make the known sound. It uses an CTM or SPM20 Russian Geiger-Müller tube. These tubes are very well known, are relatively cheap. I want to show you more details about the build. The high voltage is created, the 555 here just creates the high voltage. I don't know how much kilohertz, but then you have a doubler, and that goes up to 300-400 volts. It's a nice build. I did not buy it as a kit as it is, but I downloaded the Gerber files. Here are some botches I did. I don't know why, because I built it quite a while ago. Perhaps I didn't have the correct potentiometer, or it was too... I don't know anymore. This I did to make it a little bit louder, the beeper. Anyway, it uses 2 batteries. That's a good thing, 2 AAA batteries. There is a plexiglass enclosure for that. The files for this enclosure are on their website. I just downloaded the files, sent them to China, and they cut me the acrylic of the plexiglass enclosure that since that time it's lying in the closet and I didn't even use it, because this is just fun. Once in a while I like building kits too, yeah? Because it is just solder them together, not much thinking, and yeah, perhaps a little troubleshooting, and that's it. It's relaxing. This is not something that I'm knowledgeable enough from the nuclear or the ionizing side to make, or the software, and honestly I'm not interested. I just wanted to build a Geiger counter. So this one is from MightyOhm. Links to that, to their homepage, will be in the description. After I showed you all 3 of them, the PCBs, I will show you how they work. This one uses an ATtiny 2313. The only perhaps negative thing on that is that it is not written in Arduino, but you have to use the Atmel suite for that, or now MCP. But it works perfect. And you just hear the clicking sounds, faster or slower, and the frequency of the sounds, the LED is blinking. But as I said, you have a serial output where you can use you can work with the data the Tiny sends out. So this is the first one. Then here we have another one. It is pocketmagic.net. It's called the uRADMonitor. It's from Romania, a Romanian guy. It is equally easy to build. Everything is, except one here, an SMD regulator, 3.3 volt regulator, is through hole. This is how it looks underneath. It uses an Atmega 328, and again, this does not use the Arduino environment. You have to use Atmel Studio again for that. Yeah, works very well. This is, of course, from the software side of view, much more complicated than this one already, because it shows you a lot of information on the display. I like the information that are shown on this display, and it has additionally an option to put an Ethernet module on the board, so you can use it on an IoT home system or connect it to a database, remote database in the internet. Uses the same SPM20. It's an SPM20, let's take a look. Yep, SPM20. These are relatively cheap Geiger tubes. When I bought them, it was, I think, 12 euros, 13 euros. Now they're going up to 19 euros. They are widely available on the internet. This one has also only one button, like this one. But this represents you a menu when using this button. And the last one is this one. This is from Imperex, is called. It's not written anywhere. It's more or less the same tube. The only difference to that is that it is completely in SMD, that I like much more than the through-hole stuff. Yeah. This comes, unfortunately, the SMD things pre-soldered, and the kit in question marks are only the few through-hole pieces, items you see here, nothing else. But it comes with this 3D printed, nice 3D printed enclosure. Well, nice. It is a good 3D printed enclosure that reminds a little bit more final product of a Geiger counter. But again, to update the software, you can use this time the Arduino environment, but you have to define a dedicated Arduino port, because the Arduino is clocked with a 10 megahertz crystal. So I don't know why this has been done. This is the back. This is how it looks. So, let's take a look how this thing works. Okay, let's start it. This is how it looks. I have to... Okay, this is how it looks. It already counts the background radioactivity, but I have here some uranium glass for testing. Look how many beads. This is stuff that in the 20s and earlier people were wearing as necklaces. So let's put it near that. This is and it's starting. You can set boundaries, you can set alarms, but for now I just want to show you how this thing works. It even has a remote control. That's an IR receiver for remote control. few of the settings. Here you can remove the sound, but the sound makes it interesting. Without sound, it's boring. This is the radiation that the beads create. Then let's take something a little bit more radiative, let's say so. And I will take this one, this thing. It's a smoke detector. It's the sensor of a smoke detector. That contains, somewhere it said, Americium 235. Yeah, Americium. 241, sorry. This is how it looks. This doesn't do much because the radiation, this thing is very good shielded. But I've taken out the radioactive, the mild radioactive piece. It is this one. This is very small. I don't even know if it is this side. I think it is this side. Well, let's see what it does. Let's turn it around. Okay, that's the correct side. As you can see, this is a little bit more radioactive, but it's most alpha radiation probably, because if you put something in between, piece of paper, it's gone. So this is the Americium or Americium 241 that is in a smoke detector. This thing, this little thing, not really radioactive. If I put, I don't know, piece of paper in between, it's gone. So you can see even at this distance, the radioactivity is gone. And for something a little bit more radioactive, I have this. A friend of mine brought it from Switzerland. It is a piece of ore from a mine, because he's collecting minerals. This thing is a Uraninite. It's an uranium ore. This is a little bit more radioactive, yeah. Just by taking this thing out, it's a lot more potent. But even at this distance, and you see, red means alarm. So let's put it back. So this is the function of the Imperex's Geiger Counter Kit. So this is the MightyOhm Geiger Counter that is only noisy, and you see the counts with a LED. It is not particularly loud. This is the only problem. So these are the beads, the uranium glass beads. Let's take again the element from the ionization chamber, the Americium 241. this thing. It is very, very mild, because you see, even if I turn it around, it doesn't work anymore. So again, it works. How good, how bad, I cannot tell you, because I'm not an expert on that. I'm just showing you the electronics inside. And now let's do it with this one, the Uraninite. It's a lot more. For this particular model kit, there is a modification on the internet, that instead of the batteries, it uses an ESP32 with a display, and then you have the data shown graphically and numerically. But I didn't use it now, because I have two other ones that have a display. So let's take the next one. So this is the last one, the uRADMonitor. It has only an on-off switch. This takes a while now, because it searches the internet, the Ethernet port. I don't know how to stop that. I didn't change the firmware, but this is how it looks. Here are the beads. This one shows you the voltage of the tube and a few other information, to be honest, that I don't know. Now this thing, the element from this thing. Okay, and it reached the alarm, the danger level. I don't know how to reset this thing. Did it restart it? Yeah. Not really. Yeah. We have to reboot that. Yeah, this is a little bit annoying, this software, because I don't know how to use it. So. And the good stuff. And reach this the labels are programmable. So these are the three ones I wanted to show you. I'm not comparing them in means of functionality. Just wanted to show you the electronics inside. For me, the easiest to build is this one. This is the MightyOhm, but with a less functionality, because it doesn't have a display, but can be modded. Next comes this from uRADMonitor, from the Romanian guy. It's okay, but I don't know. It feels, I like the display, the informations, And that's it. But I don't like that it is waiting for the board itself so long, for the Ethernet board. And to change that, you have to change the firmware. You have to recompile the firmware. At the end, this is what I'm using at the moment. This is from the Lithuanian guy. It is a very simple display. It's loud. That's it. I will show you the links for all these ones. For that there is an acrylic casing too, but I couldn't use the files that are provided, or at least the shop in China couldn't use it because they told me that it is not usable. They cannot use this data. So for that I don't have any case. But it was just to build the kit, nothing else. Yeah, just to show you, for the Imperexis one, this one, the kit comes like that. This is what you get. An almost finished PCB where all the SMD parts are already soldered. Boring. Anyway, then the few through-hole parts you have and the display. I would have preferred to get it completely non-soldered at all, yeah, like this one. But it was the PCB as you see it was so cheap in comparison that if I would make the PCBs, then I have to make 5 PCBs. What will I do with the rest of the PCBs? Like this one. I have 5 PCBs of each and I'm not using it. I wanted only one because I wanted to build a kit. And all the parts are sourced by myself, or the most of them I had it already. Yeah? And this one came with a PCB as you saw it. So this is why I ordered the 3D printed case, because I don't have a 3D printer, and the kit itself, this one. Yeah, anyway, the guy that builds these ones, or that sells these ones, have a few other casings too, and for different scintillation tubes, much better ones, but okay, they are a little bit expensive. But okay, check them. I do not have to do anything with all these 3 guys. I just found them in the internet some years ago, downloaded the files. In these 2 cases, made the PCBs in China, soldered the whole stuff, and play a little bit with it. That's it. And for that, I ordered 2 of these PCBs and 1 case. Nothing else. I'm showing it to you. Perhaps you find it interesting if you're looking for something similar to build. All the links and the information to the links to informations I have will be in the description. So, this is for today. I hope you liked the video. I just wanted to show you the 3 kits I built. Nothing more, nothing less. And perhaps it is interesting for you, the links or the insides of it. The files for all 3 of them are more or less completely available public in the internet, at least of these 2. For that you have no layout. This is why I didn't make the PCBs myself. That's all for today. Thank you for watching. See you in my next video. And have a nice evening. Cheers guys. Bye.